Hi guys, let me try to solve this. Find all possible values of tangent of x such that 4 sine squared of x plus 5 equals 2025 to sine of 2x. Okay, it's probably going to be a quadratic equation since we have sine squared, and it's all possible values, so that means that there's probably going to be multiple. So, first we can simplify this. Sine squared, or sine of 2x is equal to, it's equal to, what is it? Sine of a plus b is sine of a cosine b plus cosine a sine b. So it's just 2 sine x cosine x, I believe. Yeah, because yeah, that makes sense. 2 sine x cosine x, because yeah, cosine of 2x has squares in it. Yeah, so but that's pretty bad. I don't want cosine x. If I were to, because I could replace, yeah, that's not good. So what else can we do? We know, I mean, maybe we can do this and somehow do something with the cosine of x, but sine squared of x is 1 minus cosine x, so I could get it to cosine x, but I still, cosine squared x, but I still don't think that helped me. Unless, I know, cosine of 2x is equal to, cosine of 2x is equal to cosine squared x minus sine squared x. So sine squared x is equal to cosine squared x minus cosine of 2x. Maybe that can help. I don't think so. I don't think so. We want, I mean, ideally we can get rid of sine, or we could get rid of cosine, just have it sine to powers, and then we could solve like a normal quadratic equation. But getting sine of 2x down to just sine is, I don't think it's possible. Unless we were to like square both sides. So then we had sine squared x, cosine squared x. And we could turn cosine squared x into sine squared x, or 1 minus sine squared x. I mean, we can try that. So it'd be 4 sine squared x plus 5 squared is equal to 2025 squared sine squared x times cosine squared x. And we turn cosine squared x into being 1 minus, so this is equal to 2025 squared sine squared x times 1 minus sine squared x, which is equal to 2025 squared times sine squared x minus sine to the 4th. What did I just do? Sine to the 4th x. Can that, but I can't just take the square root of that, and that's like not that helpful. Because this is a really hard equation to solve now. I think, because okay, if we have both sides, we have 4, and then we could use y squared plus 5. This thing is squared is equal to 2025 squared times y squared minus y to the 4. y to the 4. So this is equal to 16y to the 4 plus 40y squared plus 25 is equal to 2025 squared y squared minus 2025 squared y to the 4. And this is a to the 4th power equation. That is okay. So this would just be 2025 squared plus 16 y to the 4 plus 40 minus 2025 squared y squared plus 25 is equal to 0. But I can't solve 4th degree polynomials like that. Well, maybe let's go a different way about this. Find all possible values of tangent of x such that 4 sine squared x plus 5 equals 2025 sine of 2x. Maybe we could just use trial and error of known values of sine. So let's say sine of x is equal to 1. No, let's say sine of x is equal to 0. We have 5 is equal to 2025. No, 5 is equal to 0 now. So sine of x doesn't equal to 0. I guess we try one. Would that be 4 plus 5? 9 is equal to 2025 times 1 times 0. Yeah. No. Doesn't equal 0, doesn't equal 1, doesn't equal anything else. Just thinking. I don't know how. I don't know how we're supposed to do this. There's no simple identity where I can just turn 2 sine x cosine x into something solely in terms of sine of x. I don't know. Well, no, actually, I did do that. It's got to square both sides. But that just, that leaves me with something that I can't find the answer for. Well, maybe I could trial and error. I can't trial and error this. Look at how big of a difference this is. That'd be terrible to trial and error on. I mean, if you think about it and you try to draw this equation will probably, since there's only even powers, it is concave. I don't know what I'm talking about. 25 here. It starts here, and then it should be mirrored since it only has even functions. So any 0 here, there will also be a 0 here. So maybe the sum is 0, because no, that's just all the values of sine. The sum of all the values of sine will be 0. So it's gonna be like this up and then down, I think. No. It's gonna be it's gonna go very far into the negatives and it's gonna go up. Very far into negatives and it's gonna go up. Like this, I think. So there should be 4 solutions for sine, maybe 2 of them are extraneous. Which one of these would be extraneous? I don't know. I don't know how the extraneous solutions probably arise because we're squaring it and that like doubles the negatives of something. I'm not sure how I'm supposed to do this. I'm gonna look at the answer. Using double angle formulas, we get sine squared of x equals 450 sine. Yeah, 2 sine x cosine x. Dividing every term by cosine squared yields something. Yeah. So what they do is they plug this into here, then they divide every term by cosine x, so this go to tangent, this would go to tan squared, this will go to secant, and then we turn secant to tangent, and then we solve, so I didn't get this right. But I understand what you're supposed to do, it's just some kind of substitution I never saw. Or, I don't even know what I'm talking about, but thank you for watching. I will see you guys tomorrow. Goodbye.